add the CO2 chips till there's about between 7 and 10 centimetres depth. So normally we fill it up to where the label starts, and that'll give you plenty of CO2, but you need to have sufficient escape time before it actually goes off. It's absolutely essential you keep the funnel away from the neck of the bottle. If you form an airtight seal like so, you'll generate pressure and you'll have much more boiling water splashing about than you need to. So just keep the funnel lifted up, and you must ensure that there's some wiggle room between the stem and the bottle. Adopt the ear defence. You warn all around you there's going to be a big bang. Put the funnel into the bottle. We'll add the water, and straight away you see there's the white smoke, and it'll sometimes obscure your view. You can also see we're getting the splashback from the boiling water, and what you do is you continue adding till the water reaches the level of the top of the bottle. Take the funnel out, lose your glove, prepare all around you. Once the top's on, we are leaving.
We're just going to hold the spatula over the top and just very gently just allow the iron filings just to roll off. So really, I've just got a little bit like that. Literally just going to hold. In fact, you can already see it starting to take effect, OK?
It's sparking really well.
Isn't that lovely?
That's lovely.
So we're not clogging the bunsen up, and that's really important. Right, now let's just look what's happening when the sparkler's burning. We've got that core that's, you know, well over 1,000 degrees. And if we put a bit of paper nearby and catch some of those sparks, we've got sparks hitting the paper, but we're collecting some of the actual dusty particles there, so you can see that actually those hot particles are hitting it. However, if I just touch the core there, the paper's caught fire. So we'll put that into our water there. And it's all to do with the volume and surface area ratio of those particles that are coming off. What mustn't you do once the sparkler's gone out? You mustn't touch it.
Touch any.
No, that's right. We normally put it into water.
Right, because it's very... The rod itself is still very...
The rod itself has got a bigger volume compared to its surface area. So you've got your metal rod, you've got your sparks, and you've got your
it can be
sparkler.
after the sparklers ended sparkling where the damage can be done.
That's right, that's where you can get a lot of injuries.
So, yeah, and that's what happens. And can you see some bits are actually spitting off, and you can get bits around, but it's quite a violent reaction.
Yeah.
If this does happen, immediately cover the phosphorus to cut off the oxygen and contain the fumes. But there is a safe way to demonstrate white phosphorus reacting with air.
As long as it's underwater, it's quite safe. You need a fairly small slice.
OK.
I'll have a go. It's actually like cutting a stick of rock.
It's really tough, isn't it?
Yeah, quite hard. Oh, well done. Brilliant.
The reaction takes place in a flask which contains air enriched with oxygen.
Brilliant. OK.
I'm using a heated glass rod to kick the reaction off.
All right, just vertically in and then lift the glass rod straight out. All right.
Wow.
And there's the clouds of phosphorus pentoxide.
It's quite a violent reaction.
Yeah, I mean, I did put a little bit of oxygen in there out of the cylinder, but mostly it was air. But that's the phosphorus reacting with the oxygen.
Wow, fantastic.
Yeah.
You're looking a little nervous at the moment.
I'm very nervous.
Why are you nervous?
I had a really bad experience when I was at college, when I was learning to be a teacher. I got a really bad electric shock.
OK, I'm going to promise you that you won't get an electric shock from this. And the way to do that is to touch the dome onto the large dome of the Van de Graaff, and then we can switch it on. As you then gently move the dome away, the sparks will start to be formed. The further away, the bigger the sparks. Then when you've described that to the pupils, move the dome back towards so they touch. We can then switch off the Van de Graaff generator and nobody gets an electric shock. Would you like to try turning it on? So you've stepped onto the plastic container and we're now going to charge you up but without you getting an electric shock. If you'd like to put your hand onto the dome, I can then switch it on and you will start to be charged up. And already we can see your hair starting to move.
And if you take your left hand and just ruffle your hair gently, we can use that to notice that your hair is sticking up as it's repelled from each other. Now, to discharge you safely, I use a meter ruler and I bring that towards you. You take your hand off and then carefully step off the block. I can then discharge the Van de Graaff and switch it off without an electric shock. The important thing to remember is that the sphere is earthed and will give you a fast, big discharge spark. And you use that to discharge the sphere or demonstrate the sparks. The wooden ruler can discharge it slowly, and that's what you want to do when you're discharging one of the pupils from when they've been charged with their hands on the generator, because it does it slowly because it's an insulator. I'm not worried at all about teachers doing the Van de Graaff experiments, as long as they're confident, as long as they've practiced them. Because pupils get excited by the Van de Graaff, it's a good experiment to do. But the teacher, by practicing it beforehand, becoming confident, can do it in a way that is completely safe. I need some help here, please. Wendy, would you like to come and give me a hand with this? Okay, ready. Quick, whenever you're ready. Good. And close it back up again. And I'd start off a year 7 lesson on forces, wouldn't even say anything at all, just walk into the classroom, plonk it on the front and set it up like that. And it's amazing how the kids are going, what's going on there, sir? And you try and explain anti-gravity paper. And they don't believe that. And then you link into a lesson on forces, onto turning moments, centre of mass. Because what's inside is, in the corner, is a big weight. And the rest of the box is empty.
While this demonstration may seem really complicated, it's not at all. You don't need very much equipment, and it's really quite simple. A potato masher to be your teeth. 3 bowls, one for the mouth, one for the small intestine, and one for the large intestine. You need a sponge to act as your small villi in the small intestine. Lastly, a couple of buckets to act as your blood, and your toilet. Make sure you've got some water in that one to add to the sound effects. A couple of plastic bags. These are going to be your rectum and your stomach. A pair of scissors to cut open the sphincter, and you're ready to go. Start obviously with the mouth. Here is the mouth, and we're going to have a really healthy meal of baked beans, lovely. Frankfurter's chocolate biscuits, Victoria sponge, lovely. The teeth start mashing up the food. So of course we're going to add some saliva. Gets added in. Saliva contains some enzymes, and these start to break down the food. So we'll start crushing those up. One other item in the mouth which helps digestion start going is the tongue. Today my hand is going to be my tongue. Whirl the food around, getting it into a round, something like that, bolus at the back of the mouth. Down the esophagus and on to the stomach. Stomach, big muscular bag. Already it's starting to look a bit like vomit. This is a great time to take it around the class.
Find the trachea, which is the one with the ridged cartilages on, and I've got to just make a cut in it so the tube can go in. See if it's going to work. Yeah, see if it's going to work before I do anything else, and that's beautiful. That's a sensational inflating lung. And it's a good idea to put a bit of string in to hold it in, otherwise when you're moving things around the whole thing can come out again. There's a lot of mess and a lot of heavy lifting and a lot of hassle to this, but I feel that every minute of it's worthwhile for the wow factor, which we find so difficult to give kids in science now, and the awe and wonder that they get when they see this is just really well worthwhile. So that's inflating very nicely.
It's very important when you're doing an experiment that you're never ever doing it for the first time in front of a child. You want to have gone through the whole thing yourself, looking at all those potential risks, talked it through with someone else who has done it a number of times, who can tell you the risks that you might not have noticed, that have gone wrong for them, so that you're that much more prepared.
You've got to rehearse them. When you're in front of a class, you're acting. But if they see that you can do the experiments and do them efficiently and get a good effect and a little bit of drama, then you'll get their respect and they'll appreciate it.
Marvellous.